Let us study how to calculate practically internal energy and enthalpy. Internal energy du in a chemical reaction that heat evolved at constant volume. The internal energy change is measured using a bomb calorimeter. Bomb calorimeter consists of an inner vessel that is known as bomb. The cover are made of strong steel tightly fitted with a metal screw and lids. The inner vessel is surrounded by a bigger insulated vessel that contains water. It is also a thermometer and a stirrer suspended in the water to proper mixing water. And a known amount of combustible substance is taken in a platinum cup. The platinum cup has a wire attached to initiate the combustion process. The combustion is then pressurized with the excess oxygen after tight sealing it. And a bomb is immersed into bigger vessel filled with the water. Then the current passes through filament attached to platinum cup in the bomb to ignite the combustion. The combustion takes place, temperature of water rises. The temperature rise is measured using black man thermometer. This is a bomb calorimeter. What I have told, this is the oxygen supply valve, this is thermometer, and this is the platinum cup, platinum crucible, and the combustion material kept here, and combustion by this ignition wire given, and this is the stirrer, this is the water filled, and this is the heater for heating the water. How much temperature will be developed here, then it will transfer to heater, then heater will transfer to the water, heat will transfer to water. Then this is the insulating valve given. Adiabatic valve means no heat will be transferred to this wall to. This is the air space given, and this is also hard steel to insulating. Then how much after the ignition, how much temperature will be developed here, enthalpy will be, how much the energy will develop here, this will transfer to water, and temperature of water rise. Then what happens? Now the amount of heat evolved du during the procedure is equal to heat absorbed by water. The total amount of internal energy will be absorbed by water. To calculate heat absorbed by the calorimeter, platinum calorimeter, Q1 is equal to K delta T, where K calorimeter constant, which is equal to MC Cc. MC is the mass of calorimeter, Cc is the heat capacity of the calorimeter. We know this is a platinum crucible. So Then we could know this Q1 is equal to K delta T. This is the heat absorbed by calorimeter. Then calorimeter constant can be evolved burning amount of standard sample, which is heat combustion is also known. To calculate the heat absorbed by water, Q2 is equal to MW CW delta T, where MW mass of water, how much mass of water is known, and CW is the molar heat capacity of water, it is also known, 4.184 kilojoule Kelvin per mole. Then therefore to calculate the heat evolved during the process means this is Q1 heat absorbed by calorimeter plus heat absorbed by water, then multiplying 2. Therefore to calculate heat evolved delta Q C is equal to Q1 plus Q2 K delta T plus MW CW delta T, K plus MW CW delta T common. Then we will know how much internal energy is produced then by bomb calorimeter, and then we have to study how much DH enthalpy will be produced. Enthalpy can be measured a coffee cup calorimeter. It is used to measure the heat evolved at a constant pressure, that is delta H. A step foam cup is used in a coffee cup calorimeter. It works as a good adiabatic wall, means it will the wall of this coffee cup calorimeter, adiabatic wall means it does not allow heat to flow outside. It works a good adiabatic wall, preventing the transfer of heat generating during the reaction to environment. The water within the cup absorbs all the heat energy like a bomb calorimeter. We can utilize the approach for reaction that we do not significantly change the volume. The change in temperature of water equal to heat absorbed or evolved during the chemical process. It is calculated the following equation: Q is equal to MW CW delta T, where MW is the molar mass of water, CW is the molar heat capacity of water, and T delta T is a small change of temperature. We can calculate by this. Thermometer is given here to measure the temperature, insulated stopper is given, and the reaction mixture is here, and this is water also given for absorbing the heat. Then we could calculate the how much delta H enthalpy of the system by Q is equal to MW CW delta T, where MW is the molar mass of water, CW is the molar heat capacity of water, 4.184 kilojoule per Kelvin per mole.